Find open circuit impedance parameter. Impedance parameter means it is Z parameters. So you have to find Z parameter for the circuit shown, and you have to determine whether the network is symmetrical and reciprocal. Is the additional question. So here again I already told, in the two-port network, suppose if I consider this is a box, okay, this is a full side, entire is a box. Input side is this, so I1 and V1 are the input variables, I2 and V2 are output variables. So you have to use clockwise direction here anti-clockwise direction only for two port. In mesh analysis we consider all clockwise only. For two port networks this should be clockwise, at the edge it should be anti-clockwise, because in the two port we have taken two port networks. The symbol initially we derived all the expression like this only. So we consider I2 like this, I1 like this. So to retain the direction of the current as like this, and middle you can use clockwise only. Apply KVL for mesh 1. Okay, apply KVL for mesh 1. So I'll write plus minus plus minus plus minus, because I2 it is also from higher potential to lower potential, plus minus for I2, and for I3 this is plus minus plus minus plus minus. Now apply KVL formula. Minus 2 plus, you can write here minus. This I told no, different author uses different notation. In this book they used minus 2 plus as positive. So in the other problems I explained, that is which one is coming first. So I am writing that one. So if you bring all throughout, you multiply by negative. This full equation, if you multiply by negative, you'll get minus. This minus becomes plus. Don't multiply here, only this, because this is a term. This is a net current. Okay. So now you see how I got this equation. Minus 2 plus. So minus V1 plus, this is plus, this is I1, this is I1, this is I2, this is I3. Okay. I1, and see the direction of the current. I1 is clockwise in 1 ohm and I3 is going opposite. So it is I1 minus I3 plus 2 plus 2. I1 and I2 is 6. I1 is down, I2 is also same direction. I1 is also coming down, I2 is also coming down. So both will get added here. So I1 plus I2 is equal to 0. So if you simplify this, V1 is equal to 3I1 minus 2I2 minus I3. If you simplify this, V1 if you bring it to right side, it becomes positive. I1 plus 2I1, that is 3I1. Then 2 into I2, 2I2, 1 into minus I3, it becomes minus I3. So equation number 1 is over. Similarly, apply KVL for mesh 2. This is a mesh 2. Don't consider middle one and mesh 2. In two port networks, input side mesh 1, always output side is mesh 2. In between, whatever is coming, that we have to consider as mesh 3. Now apply KVL for mesh 2. Start from here. Okay. Start from here. You get minus V2. Then plus, this author uses different notation. Plus 3 into, plus 3 into. So if you have this copy, you can hard copy of these notes and you can change the polarity like this. Or if you understood, it is okay. So plus 3, how many currents are flowing here? This is going plus 2 minus. This is also going to plus 2 minus. So both the current directions are same. Both will get added. I2 plus I3 and plus 2. Okay. Plus 2 plus 2. And again here also I1 and I2 directions are same, matching, plus 2 minus plus 2 minus. So I1 plus I2. So if you simplify, V2 is equal to this V2, you bring it to right side. V2 is equal to 2I1, 2I1, 3I2 plus 2I2, 3I2 plus 2I2, total 5I2, and plus I3 term is also there, 3I3. So this is equation number 2. So actually in Z parameters, V1 and V2 are expressed in terms of I1 and I2 alone. I1 and I2 alone. But here extra term is there, I3. Here also there, it is also there. Okay. So you have to eliminate this I3. So to eliminate, you have to obtain by writing KVL for mesh 3. If I writing KVL for this mesh 3, okay, if I write KVL for mesh 3, then here you can see start from 4. Okay. So this is another notation. So I told no, if you are getting opposite, throughout multiply by negative. So this becomes plus. So they used this one minus, this minus, this minus. I am using first. Which one I am getting first? Plus I am getting here. Here also I am getting plus. Here also I am getting plus. In this notation, originally it was minus, minus, minus. I am using plus, plus, plus. Both are correct. Throughout multiply by negative will give the same answer. Okay, now see here 4I3 in 4 plus now 4I3 in 3 I3 is flowing, I2 is flowing. In 3 ohm, I3 is flowing, I2 is flowing. It is matching. So I2 plus I3. Again in 1 ohm, okay, this is plus to minus, this is minus to plus. So I3 is going left side, I1 is going right side. So you have to take difference between I3 and I1. So I3 minus I1 is equal to 0. Now you have to obtain expression for I3 here. So I1, 3I2, 8I3 is equal to 0. Okay, then mm, this is 4I3, 3I3, okay, 4I3 plus 3I3 plus 1I3, 8I3, then 3I2, okay, then I1. So this also I think you have to change. Okay, let me add 4I3 plus 1I, 3I3, 7I3 plus an 8I3, then 3I2. Here I changed the no, so this should be 3I2 and 1 into 1 minus 1I3. So it is same one only. See, I3 is equal to 8I3 is no. So I3 is 8I3 is equal to, if you bring this I1 to right side, it becomes I1, and this 3I3 becomes minus 3I2, and 3I3 is that much means I3 is equal to divided by 8. So I3 is equal to 1 by 8 I1 minus 3 by 8 I3. So this same expression only you are going to get. With original opposite notation of KVL, you will get the same answer. Here I threw out multiply by negative, then also I got the same answer. So you can use this method only. So now I3, no, what is the solution? I'm repeating once again. In any two-port networks, if they give like these three meshes and all, write KVL for mesh 1, KVL for mesh 2. That is input side and output side. And you are going to get additional I3 term in both equations. So how to eliminate means write KVL for mesh 3 and obtain expression for I3 like this. And now substitute I3 value here and here. Then you'll get V1 and V2 in terms of I1 and I2 only. So here it is substituted. Here it is substituted. So in equation number, if you substitute the value of I3 in equation number 1, 3I1 plus 2I2 minus I3. No, I3 value is 1 by 8I1 minus 3 by 8I2. So if I simplify this 3I1, this I1, this is also I1 term. So 3 minus 1 by 8. 3 minus 1 by 8. Again, I told how to do that in the calculator. You can do like this 3 minus 3 minus 1 by 8. You get 23 by 8. 23 by 8. Similarly, 2 is minus into minus. minus into minus is plus, minus into minus is plus. So 2 plus 3 by 8, 2 plus 3 by 8, 2 plus 3 by 8. If you take LCM, no, 8 is LCM, 2 8s are 16 plus 3 is 19. Okay, 16, 19 by 8. So this is equation number 1. Similarly, obtain substitute the value of I3 in equation number 2. So V2 2I1 plus 5I2 plus 3I2 was there, I3 was there, I3 value is substituted here. Now after substitution 2I1 and 3 by 8 I1. I have to add these 2I1 plus 3 by 8. So again you can add using calculator 2 plus 2 plus 3 by 8. You will get again LCM is 8. 2 8s are 16. 16 plus 3 is 19 only. 19 by 8. And last one 5I2 into 3 into 3. Don't forget you have to multiply 3I3. No, you have to multiply with 3 into 3 is 9. And you have to subtract 5 minus 9 by 8. 5 minus 9 by 8. So 5 minus 3 3s are 9. 3 3s are 9 by 8. Again LCM is 8 only. 8 5s are 40. 40 minus 9 is 31. 31 by 8. So this equation number V2. This is in terms of. So we know that V1 Z parameter equations are V1 and V2 are expressed in terms of I1 I2. V1 is expressed in terms of I1 I2. V2 is also expressed in terms of I1 I2. There is no I3 term. There is no I3 term in this. So coefficient of I1 in V1 equation. This is Z11 23 by 8 ohms and Z12 is 19 by 8 ohms. Z21 is 19 by 8 ohms. Z22 is 31 by 8 ohms. It is a impedance parameter, no unit you have to write as ohms. Okay, and ask whether circuit is symmetrical or not. For a symmetrical network, Z11 should be equal to Z1, Z11 should be equal to Z22. So it is 23 by 8, this is 31 by 8, so it is not symmetrical. Is it reciprocal? For reciprocal, these two, Z12 should be equal to Z21. So 19 by 8, 19 by 8. So this is circuit is symmetrical, sorry, reciprocal, but the circuit is not symmetrical. Okay, this is additional. Sometimes they will ask, normally they will ask only find Z parameters only. Okay, thank you.